lower. Thus, Mars has been able to retain an atmosphere. Because remember how Mercury's atmosphere is very like iffy. It's very on and off, if you know what I mean. Mercury is very close to the sun and it's very much smaller, so it doesn't retain an atmosphere very well. But it will have on and off atmosphere because of its proximity to the sun, and some of the solar stuff will get kind of trapped near Mercury, giving it sort of a transient atmosphere. This is called Foundations of Astrophysics by Barbara Ryden and Bradley M. Peterson. I cover a lot of topics from this book on my lives, you know, so you could just come to my live streams and be covered. Also, if you're interested in all of this, you should subscribe, and also you should check out the older live streams, which will have a lot of these topics covered in those episodes already. So I've been going live for a while, so you can always go and check out these topics in older lives and just like listen to them in the background while you're like doing dishes or something, you know? So you don't need to buy the book because it's pretty much covered in the lives. A lot of these discussions we've covered already. We were actually not on this book right now, but I came to it because of the questions about Mars and whatnot. And thank you so much for being here. And can we get 10 likes? Okay. So another similarity with Earth is that the length of the solar day on Mars is 24 hours and 40 minutes, which is very close to our 24 hours. Although Mars, as in our solar day, although Mars has an escape speed comparable to that of Mercury. So Mars is very much smaller than Earth. So its escape speed is comparable to that of Mercury. Its daytime temperatures are much lower. So because its daytime temperatures are much lower because of being so far away from the sun, so it's not like its atmosphere is like constantly blown away like on Mercury, right? So although Mars, thank you for the emojis, thank you for the hearts and all that stuff, engaging and whatnot. Thank you so much, really appreciate it. Okay, so although Mars has an escape speed comparable to that of Mercury, its daytime temperatures are much lower. Thus, Mars has been able to retain an atmosphere, which is very nice. Having an atmosphere is good. Unless it's poisonous like on Venus, then it's not as good. But having some kind of atmosphere is actually nice because that also makes it kind of similar to Earth. However, the air on Mars is thin. The average air pressure at the surface of Mars is 0.006 atmospheres. Compare this to the pressure on Earth at sea level, which is an atmosphere, 1 atmosphere, versus 0.006 atmospheres. So the pressure is very low there. The Martian atmosphere is 95% carbon dioxide, similar to the atmosphere of Venus. So also kind of a bummer is that it has a ton of carbon dioxide without the liquid water. There is little water vapor in the atmosphere of Mars. This is because UV light dissociates it. Mars with no oxygen in its atmosphere doesn't have an ozone layer to absorb the UV light. So bummer, a lot of carbon dioxide. I mean, we had it too. Earth had a lot of carbon dioxide too, but because of our liquid oceans, we were able to trap some of that carbon dioxide in the water and convert it to limestone. And that's actually how we cleaned up our atmosphere over the ages. And here we are now to breathe it and pollute it. So, a water molecule is dissociated into hydrogen molecule and an oxygen atom. The low mass hydrogen molecule escapes into space and the oxygen combines with iron in the Martian soil, making the ferric oxide that gives Mars its distinctive reddish color. So the distinctive reddish color is basically rust, right? It's iron oxide, it's ferric oxide. If you just had iron, that wouldn't do it. It's really the combination. It's really the chemistry with oxygen, which makes that rust, just like we have rust here on Earth too. So that's the reddish color. The surface of Mars is about 44% silicon dioxide, which is sand. So this is where what I meant about the surface of Mars being kind of similar to ours. Our surface has a lot of silicon dioxide as well, like sand, beaches, things like that, right? So Mars's surface is kind of similar to ours. So in that sense, if you walk around on Mars, you'll feel lighter and you'll think that it's, oh, this is so nice and sandy. So you might like it.